Hi, welcome everyone, and thanks you for joining us today. I'm delighted to have with me Piotr Wegner, someone who has spent the last several years doing what most organizations are only beginning to attempt, actually taking AI out of proof of concept phase and making it work in real complex production environments. So today's conversation is called From Fragmented Data to Reliable AI Answers. And over the next 45 minutes, we are going to get into real engineering and organizational challenges behind the journey. So no theory for theory's sake, just real problems, real patterns, and real lessons. And let's get into that. Let me start with the question that I think most of people in our audience are sitting with right now. Every vendor, every analyst, every conference keynote is now saying that AI is transformative, it is ready, and they need to move on now. So do you agree?
Yeah, thank you. Well, I agree that AI is genuinely transformative, but I disagree quite strongly with the idea that is ready to be dropped into a complex organization without serious engineering work underneath it, right? And I think that distinction is where most organizations get into trouble. So they hear transformative and they interpret it as frictionless. They see a demo where someone types a question into a chatbot and gets a perfect answer. And they think, right, we just need to connect this to our data and we are done. And that's not actually what happens in practice. What happens in practice is that the model is capable, but the conditions required for it to perform reliably simply do not exist yet. So the data is fragmented, the documents are layered and contradictory sometimes, the context window fills up with noise, and the output starts to drift, basically, right? So the question we should ask at the beginning of the engagement is not, can AI answer this? Because in most cases, the answer is basically yes. But the question we should ask is, have we built the conditions under which AI can answer these questions reliably every time? And in a way, you can stand behind, actually, right? So this is a completely different question, and it is the one we are going to spend the next minutes on, I believe.
Yeah, I love that framing, the conditions for reliability. And before we get into specific cases and solutions, could you please explain a bit more what do you mean by fragmented data? Because I think that phrase means different things to different people.
Right, yes. You're right that it means different things. So when most people hear fragmented data, they think of the classic IT problem. So data sitting in silos, in different systems, different formats. And I mean, that is part of it, of course. But when we talk about fragmented data in the context of AI, we mean something more specific and honestly more dangerous even. So we mean that data that has no clear authority structure. Like, for example, data where a document from 2020 and addendum to this document from 2025 sit side by side in the same repository, and nothing tells the AI which one takes precedence. So we mean, conversational histories where the users have shifted topics 3 times, and the model is still trying to reconcile everything into one coherent answer. We mean knowledge bases built by hundreds of different people in completely different styles with completely different levels of detail. So in each of these cases, the AI is not broken. It is doing exactly what is designed to do. So basically, it finds patterns, it makes probabilistic connections. It generates the most statistically likely answer, right? But the problem is that the data underneath, well, it doesn't reflect a coherent reality. So the output reflects that incoherence back to the user. and yeah, and often with some confidence, right?
I see. And you used the word probabilistic. I'd like to push on that a little bit because I think this is the one of the words that gets used a lot by people, but they don't always understand the practical implication of that. And what does it actually mean for an organization that is trying to use AI in a real workflow?
Yeah. I mean, it means you are never getting a guaranteed answer. So you are getting the most likely answer given the data the model has access to. And in many contexts, customer applications, creative tool, internal assistants, answering some general questions, this is perfectly acceptable. Close enough is good enough. But the moment you move into regulated environments, right? So complex operational workflows or any domain where a wrong answer has a real consequences, most of the time is not a standard you can build process on. So imagine you hire a consultant who gives you correct advice 95% of times, right? So that sounds quite excellent in the beginning. But if that consultant is advising on, I don't know, 50 decisions a week, they are giving you 2 or 3 wrong answers every week. So, those errors do not stay isolated. They compound over the time. So a wrong input at step 1 propagates through steps 2, 3, 4, and so on and so on. And by the time you reach the output, the drift from reality can be significant. And this is what we call the probability trap. And the way out of it is not to find a better model. It is to engineer the system around the model so that this probabilistic nature is constrained somehow, grounded, and auditable.
Yeah, I see. So the answer is not in the architecture, but is in the architecture, but not in the model itself.
Yeah, exactly. The model is the last thing you should be optimizing, in my opinion. So the data layer, the retrieval logic, the guardrails, the security, those things come first, in my opinion. And I will come back to this when we talk about some lessons in the end of this session. But I want to plan that idea now. So prompt engineering is not the foundation. It is the finishing touch on top of the foundation that either exists or not right now. And I believe that the best way to illustrate what the foundation looks like and is to walk through some real situation, right? So we worked on some of them in past months, so I believe we can get into the cases.
Yeah, let's do it. And I understand those are real projects, real problems, but just without the client names.
Yeah, of course, correct. I mean, not all the customers we can reveal, but these are real cases. So the problems and the solutions are real, and the patterns they represent are quite universal, in my opinion. So that is actually the point. These are not exotic edge cases. Every organization with a reasonable amount of operational complexity will encounter some versions of each of these. Yeah.
Great. So could you please tell us about the first case? What was the problem there?
Right. Okay. So this one came from a public sector context, a body responsible for managing an enormous amount of regulatory documents. We are talking about thousands of pages across dozens of source types like PDFs, CSVs, data gathered through APIs, some internal wikis, some scraped content. So, the critical point was document hierarchy that was deeply layered and frequently contradictory, right? So in that kind of environment, if there is a new document, a new addendum which overrides older standard, Yeah, sometimes a local regulation take precedence over a global one. Sometimes a specific facility type is governed by different rules than a general one. So for a human expert, navigating that hierarchy is years of training, right? To understand the structure, what should go first and what should go last. So, and yeah, you need to have this knowledge. And the organization wanted to make that knowledge accessible through an AI assistant. So someone should be able to ask a question, I don't know, for example, what are the carbon offset requirements for a healthcare facility under the 2025 standards, for example, right? And you need to get a precise, trustworthy answer for that.
Mm-hmm. And what happened when they tried to the straightforward approach, just feeding the documents to an LLM?
Well, what almost always happens. So the model answered confidently, and it was right, roughly 80% of the time, which in most contexts would be considered a strong result for the first implementation. But in regulatory context, 80% is 100% failure. So the 20% of cases where it was wrong were not random. They were precisely the complex layered cases where a human would have spent the most time cross-referencing. So the cases were getting it, the cases were getting it wrong. Well, they were quite high with the consequences, right? So the model was not hallucinating. It was not inventing new facts. It was making just plausible inferences across documents without understanding which document held authority over which. So it was treating similarity as equivalence. And that is a structural problem, not a prompt problem, right? Not a model problem.
Mm-hmm. And what was the solution?
Well, we introduced what we call hierarchical retrieval augmented generation, HRAG. So the core idea is that before the model ever touches a document, the system understands the authority structure of the whole base, right? So we mapped every parent-child relationship in the document hierarchy, and the AI knows that document A is the governing standard and document B is a commentary or addendum to this document. And when a question arises, the retrieval logic does not simply search for the most semantically similar fragment, but it follows the authority chain, right? So it starts at the top of hierarchy and drills down. And the second element was cross-document correlation. So if someone asks about, I don't know, ventilation requirements, the system does not just find the word ventilation. It traces the full path, core standard, then facility type, then local override, before assembling the final answer. And the third element, I believe that's the most important one, is what we call the citation constraint. So we configured the system so that the model is not permitted to answer a question if it cannot produce a source citation at paragraph level from the governing document. So if the supporting document does not exist in the hierarchy, then the model does not guess. It says, I cannot find a source for this. Yeah, here is only the things I can confirm.
Mm-hmm, I see. And that citation constraint is interesting from a broader perspective. Is that something you see becoming a standard practice?
Well, I believe it will have to be as AI moves deeper into regulated industries, like legal, financial services, healthcare, public administration. The ability to ground every output, every answer in a verifiable source is not a nice to have. It is the condition under which any responsible organization can deploy these systems. The model that will win in enterprise environment is not the one with the highest benchmark score. It is the one they can say, here is my source for every claim they make, right? So what we built for that project, I believe, it's a preview of what enterprise AI architecture will look in coming months even, right? So the organizations that are building those capabilities now are not just solving today's problem, they are building something for a structural advantage in the future. And of course, it is related with AI Act, for example, which will be the standard, legal standard in coming months.
Yeah, great. So let's move to the second case, and you called it context poisoning, which is a phrase I have not heard before. What does it mean?
Yeah, so second situation, and let's start with the context poisoning. So context poisoning is what happens when the accumulated history of conversations starts actively degrading the quality of the answers. So yeah, here's the situation. Imagine some kind of large retail network, like hundreds of locations, all operating under a central set of processes defined by the headquarters, processes covering everything, like how to manage inventory, how to arrange products on shelves, how to prepare food within the standards, how to control temperatures in the fridges, what is the customer service protocol, right? So quite a significant operational knowledge base. And they deployed an AI assistant so that the operators in this points of sale could ask questions to get instant, reliable guidance. So during the test, it worked quite well. Operators would ask a question, get a clear answer, and move on. The problem emerged in real usage when operators started having longer multi-topic conversations with the system. So someone would spend 10 minutes working shelf stacking logic, right? And then they would ask about the pizza oven temperature. And the model still carrying the full context of the shell conversation, and it would attempt to find a connection between these two topics. So it might suggest stacking the pizzas vertically, for example. It might apply shelf spacing logic to over configuration. So answers that were internally coherent from the model's perspective, but they were quite dangerous in practice, right?
So the model was not wrong in abstract, it was just applying the wrong frame of reference, yeah?
Yeah, exactly. And this is a broader point about how LLMs handle context. The context window, this accumulated conversation history is not neutral. It is a lens through which every subsequent question is interpreted. So the longer and more varied the conversations are, the noisier they become, right? So in a consumer application, this is manageable. A user can simply start a new chat. But in an operational environment where operators are working through multiple topics during a single shift, asking them to manually manage the AI's memory is not a valuable solution, actually. So you need to have the system to manage it for you.
Yeah, I understand. And how did you approach that?
Well, through something called context engineering. So there are some mechanisms working together behind. The first is context pruning. We developed logic that detects when the user has made a genuine topic shift, moving from logistics to food safety, for example, right? When that shift is detected, the system intelligently removes the irrelevant context from the active window. The model is not, burdened with shelf stacking information when it's answering a question about oven temperatures, for example. Second mechanism is state awareness. So rather than one continuous memory, we introduced a modular approach. So the system knows which operational domain it is currently in. So whether it's food preparation or shelf stacking or inventory or customer service, and it activates the appropriate guardrails and knowledge for that specific domain, and moving others away, right? And the third is what we call the hard reset. So sometimes the context window becomes, quite noisy before any topic shift is detected. So in those cases, the system proactively trying to find out from the user with some clarifying questions if the context changed. So essentially resetting the frame before answering, rather than attempting to once again synthesize across some different contexts.
And from a broader AI adoption perspective, is context management something organizations are thinking about seriously enough?
I'm not sure enough. It's a right word. So most AI implementations treat the context windows as a feature. The engineering reality is that it is also a liability, of course, if it's not actively managed. So AI assistants become embedded in operational workflows, and they will across every industry, in my opinion. So the organizations that perform best will be those that have thought about that carefully, and how they can carry this through the models. And the context is not just a technical parameter, right? It is a design decision with direct operational consequences.
Yeah, okay, thank you for sharing. And the third case is an internal one. I understand this is something Britenet built for itself. Could you tell us more about that?
Sure, yes. So I think it's worth including our own cases because it shows that it's not only doing something for the customers, but using these features by ourselves as well. So we faced the same data quality challenges like our customers, right? So imagine the situation. We have approximately 1,000 engineers, specialists on board, and hundreds of projects running across any given year, and some quite stable, persistent operational challenge. How do you match the right person to the right project opportunity? Quickly, accurately, based on their most current and relevant experience, right? So obvious answer is a CV database, basically, right? But the practical problem is that a CV database is only as good as the data inside it. And when you ask 1,000 technical specialists to maintain their own professional profiles, what you get is 1,000 different levels of details, 1,000 different writing styles. So basically, a very uneven picture of actual talent you've got available on board. So some engineers write in bullet points, some write in full paragraph, some list 3 technologies and nothing else. Some write in a conversational style that is more like a chat message than a professional document. So the data is technically there, but it is practically unusable for reliable semantic search.
Yeah. So you have the data, but it is too inconsistent to query effectively.
Yeah. So that is the data entropy problem, right? So you have information, but the format variation is so significant that a system searching for, I don't know, Java experience in a fintech context will miss qualified candidates because their entry says something like, worked on banking stuff, lots of Java, pretty complex, right? Theoretically, it should be matched. And so a keyword search fails in this kind of situations, and basic semantic search still struggles because the embeddings are built on inconsistent inputs. So the signal to noise ratio is too low.
Yeah, and what was the solution for this situation?
Well, first, and this is the element I'm proud that we designed that we removed the friction from the human side entirely. So we introduced what we called a write as you are policy. So specialists update their experience in whatever form is natural to them. As I mentioned, bullet points, casual sentences, technical shorthands, whatever. We stopped asking people to conform to a format the system could, enforce. The second thing, we built a semantic aggregation layer. So the raw input, however it is written, is fed into a semantic database with embeddings. The system does not search for the word Java. It understands the context of experience, the seniority, the domain, the complexity of the project described. A candidate who writes, build the transaction engine for a mid-sized bank is correctly associated with fintech and backend engineering without those words appearing anywhere in this text, right? And the third thing, we added a LLM layer that functions as a professional editor. So it takes raw colloquial input and produce a standardized high-quality CV in the Britenet voice, right? According to our brand tone, without having specialists to do anything during this process. So still, human provides the substance, the AI provides the presentation.
Yeah, that's a fascinating version of the usual approach. Instead of asking humans to adapt to the system, you build the system to adapt to the humans.
Yeah. And I think that is the broader principle that organizations need to internalize as they scale AI adoption, actually. So the systems that will actually be adopted, not just piloted, but genuinely embedded in daily workflows, are the ones that reduce friction for the human, not the ones that demand compliance from the human, right? So every AI initiative I've seen fail at the adoption stage has failed for the same reason. It asked people to change their behavior before it delivered value to them personally. So we turn that sequence around. The specialist gets a better CV, the project manager gets faster, more accurate talent matching, the system earns its place in the workflow because it makes both parties jobs easier, actually. So that is how you get genuine adoption, not just executive mandate. And I would extend that principle far behind, I don't know, HR or talent management. Any AI system you are considering, ask yourself, who is being asked to change their behavior to make this work? If the answer is the end user, your adoption rate will disappoint you, definitely. That question is now one of the first we should ask in every AI engagement we take. So because the answer tells us more about the likelihood of success than any other technical specification.
Great. Thanks for sharing all these cases. They're really useful, I believe. And now let's move to the moment when the organizations go from the proof of concept, from the pilot stage to production. So let's say the organization ran a proof of concept phase, and then they're trying to scale it, and they figure out that it is more difficult, more challenging than they expected. What organizations do underestimate?
Well, almost everything, of course. But yeah, to be more specific, well, when we say it is harder than you think, it's not very useful advice, right? So the first thing organizations underestimate is what we call the infrastructure tax. And we had these examples also. So in a pilot, you demonstrate the capability. You show that the model can answer the question. What you do not show, because you are cutting corners to move quickly, as you should in pilot, is everything that needs to exist underneath, which is needed in production environment. So you need data pipelines feeding the databases in near real time. You need some OCR tools handling poor quality scans. You need automated metadata tagging. You need a security layer that enforces your existing identity and access management rules. If a user cannot access a document in I don't know, in SharePoint, that AI should not be able to access it either, right? So regardless of how the question is phrased, you need token monitoring and cost control, because without them, a single poorly scoped query in a production environment can generate significant unbudgeted expense. All of this work can consume up to 80% of your pilot budget before model answers a single question in production. And we saw this kind of examples. Organizations that are not prepared for that are in very difficult situation.
Yeah, so 80% figure is really striking. And do you think this will reduce as the technology matures?
Well, it will reduce. The tooling is improving rapidly. So even if when we planned this webinar, I wasn't sure that the topic will be still relevant, but fortunately it is. But there are better managed services for the databases, better frameworks for RAG pipelines, better observability tools. But the fundamental change, that your data is messy, your access controls are complex, and your security requirements are non-negotiable, well, that does not disappear because the tooling gets better, right? So the infrastructure tax will reduce, but it will never go to zero. And second thing organizations underestimate is the organizational work required on the business side. So this is not an IT problem to be handled, but rather moving to production requires the business to appoint what I call an AI steward, someone who owns the semantic lifecycle of the data that this AI depends on. So if your regulatory documents change, someone needs to be responsible for ensuring that AI's knowledge base reflects the change, because AI will never know about these changes, right? So if a new policy overrides an old one, that authority relationship needs to be updated in the system. If the AI starts producing answers that feel slightly off, a human needs to have this mandate and the capability to investigate why. That is not an IT role. It's a business role, and it needs to be defined before you go live.
Yeah, that makes a lot of sense. So we can say that it is as much organizational challenge as the transformative one, yeah?
Yeah, I believe so. So it's like a pan-organizational challenge. And I believe there is other thing there. In a pilot, success is often defined by the reaction in the room. The demo looked impressive, the stakeholders were engaged, the answers felt right. That is fine for a pilot. It is not a production standard, right? In production, you need what we call golden data set. So a curated set of questions with verified answers defined by the business that the system is tested against every time a developer changes a single line of the prompt logic. If you modify the prompt to make responses, more concise, you need to know whether that change improved accuracy, degraded it, or had no effect. You cannot know that without you cannot know that without proper benchmark. So this golden data set is not a technical artifact. It is a business artifact. The business defines what the correct answers should look like, and the technology is measured against that definition. And that is the feedback loop that turns up promising pilots into a production systems.
Great. So this is the way you understand that the system is performing properly, that it is going as expected, yeah?
Yeah, exactly. So the technical work is significant, but it is, not everything. The organizational work, getting the business to own the data, define the standards, appoint the stewards, and commit to the feedback loop. This is the harder, longer work, and it is the work that determines whether AI investment produce lasting value, or it's just a very expensive proof of concept, right? And it quietly gets shelved a couple months later.
I see. So before we move to the final word, first of all, thanks a lot. That was really insightful. I would like to see if we have any questions in the audience. And meanwhile, if I can ask you some questions before, while we wait for questions coming in. What do you see as the biggest organizational challenge, the most organizational constraints that appears?
Well, the awareness. Many organizations believe in their own perspective, own vision of reality. So they believe they are ready, for example, right? So they believe their data is good enough, or they've got everything in place to start, using something more sophisticated. And in my opinion, this is like a cardinal sin we all, be doing, and that's why you need to have someone like from outside the organization to audit you, to check if there is everything in place before starting any kind of operations around this topic.
Mm-hmm. Great. So I think we don't have any questions for now from the audience, and we can go to the final word, the 5 lessons that you would like every organization to remember. Could you please tell us about those questions? What is the lessons? The lesson 1?
Yeah. I mean, when I prepared for this, I thought about 5 things we should have drawn outside of this content. So first of all, I called it collaborative evaluation. So we define what good looks like before we build anything. So the business must produce this golden standard, a set of verified authoritative answers, and the system is measured against on every iteration. And so without this definition, you have no way to know whether a change to the system improve it or degrade it. So you are not engineering, you are just guessing, right?
Mm-hmm.
The second one, I called it translation as a service. So if the business cannot define the process, the AI cannot automate it. The AI handles the probabilistic part, but it needs deterministic constraints to stay on track.
Mm-hmm.
Well, from the technical point of view, these could be, I don't know, JSON schemas, some decision trees, versioned set of rules. But if the business cannot express the process at that level of precision, That is the problem to solve before any model is involved.
Mhm.
The third lesson, I believe the prompt engineering is not a king. So prompting is the last step, not the first step. And a well-crafted prompt on top of fragmented, unstructured data produce a confidently worded wrong answer. Build the data layer, structure the retrieval logic, enforce the guardrails, and then optimize the prompt. So architecture sets the ceiling. The prompt works within this room, right?
Mhm.
The fourth one, and I really like this metaphor. So AI is a mirror of your data readiness. So your AI will reflect the quality of your data, and it will not compensate for it. In every project we have run, the majority of technical effort goes not into the model, but into cleaning, structuring, indexing the data beneath it all, right? So data readiness is not a prerequisite you complete before the work starts.
Mhm.
It is work. It is actual work. And the last thing, which is, I believe, nowadays more and more important, is the protective shell. So build a guardrail layer between the user and the model, and treat it as infrastructure from day one. So you need to I mean, this layer is what your C-level and legal team need to see before any deployment is approved, because you need to build it first and then get the sign-off, because it guarantees your security in many contexts, right? Against the law, against the common sense even. So yeah, I believe these are 5 tangible things we should consider before starting the projects in this area.
Great, thanks for sharing. I think those are really useful and practical. And so, if you would like people who are now watching us to take one single idea from today's conversation, what would you like it to be?
So one single idea, these things we discussed today, they are quite nice, sexy, sophisticated in some cases. But before you start trying to build that, look in the mirror, check how your data looks like, if you are ready for this kind of operations, because if you are not, even pilots will not bring you any value.
Mm-hmm. Yeah, okay. Thank you so much. And for those who would be interested in continuing this conversation, what would the best next step be?
Well, of course, contacting us, right? We've got amazing consultants on board, and they can bring these conversations to the next level, whether these are more business driven or technical driven. We will handle both types.
Amazing. Thank you so much. That was really very rich, honest, and practitioner level conversation that I think our audience needed. So thanks everyone for joining today, and we will see you on the next one. Bye.
Thank you.